Welcome, everyone. My name is Amber Dance, and I am the Program Director at the Council for the Advancement of Science Writing. This webinar today is a joint effort of CASW plus the American Statistical Association. So we thank our partners and participants from that organization for working with us to make this happen for you all. Conveniently today, the National Academies of Sciences, Engineering, and Medicine released a new report on extreme weather events and climate change attribution. So we've clearly hit on a hot topic, so to speak. We'll share the link to that report in the chat. So as folks continue to trickle in, I'd like to take just a minute to introduce you guys to the CASW Connector, which is a resource that CASW created a couple of years ago, and it's sort of like one-stop shopping for all kinds of resources in science writing. So this is the connector site, and there's two main ways to use it. One is to click here on Explore Full Library, and it gives you these various options you can sort by. So you can look for resources for educators or mid-career journalists or scientists or students, all kinds of stuff. Or you can sort by topic. So if you're looking for an award to apply for, there's 85 different award options. If you want fellowships, you can look for fellowships and find 11 options to look for here. The other option is to go through the search. So for example, if I go and type in climate attribution, it'll link to a whole bunch of resources related to that. A video on understanding and communicating the link between climate change and extreme weather, a video on turning climate data into stories, training programs, et cetera, et cetera, et cetera. So there's already a lot of cool stuff in there, but one of the things we're hoping to do in today's webinar is to add any resources that you guys, attendees, know about related to the topics at hand, whether that's statistics or data analysis or attribution of events to climate change. So one of our speakers, Sarah Kaplan, has gotten the ball rolling. She's put together a really awesome tip sheet with various resources that she uses in her reporting at the Washington Post. And another speaker, Chris Wikle, also added a bunch of references to that. So we'll be sharing that in the chat. So if at any point in the webinar you feel like you've got a resource or a tip to share, please go ahead and post that in the chat, and we will incorporate those into a final tip sheet that we'll share with everybody after the webinar. So without further ado, I would like to welcome and introduce our moderator and one of the co-organizers of this event. Regina Nuzzo is a professor of math and data science at Gallaudet University, and she's also a science journalist specializing in statistics and the scientific process. If today's event leaves you wanting more statistics with a sassy slant to it, check out the Normal Curves podcast, which Regina co-hosts. Regina, the floor is yours.
Thank you, Amber. I am so excited about this webinar today because I think we're bringing together some very important people who sometimes live on opposite sides of the wall. So it's going to be fun to get them together. First, I want to introduce Chris Wikle. He's at the University of Missouri. He's the Curators Distinguished Professor of Statistics. He has advanced degrees in both meteorology and statistics. His specialty is in spatio-temporal statistics, and his applications are weather, climate, the environment, and geophysical and biological processes. We have Jason Samenow. He is the founder and chief meteorologist for Capital Weather, and he described this company as dedicated to providing trustworthy DC area weather coverage. He was previously at the Washington Post as a weather editor and worked in a previous life as a climate change analyst at the U.S. Environmental Protection Agency. And last, we have Sarah Kaplan, who is a climate reporter at the Washington Post, and she covers humanity's response to a warming world. And her reporting focuses on extreme weather, as well as the impacts of climate change on food, water, and biodiversity. And Sarah was part of the team of Post journalists that were recognized as a finalist for the 2025 Pulitzer Prize in National Reporting for coverage of Hurricane Helene's human and environmental toll. And Sarah previously reported on earth science and the universe at the Post. And I think that we are going to drop into the chat Sarah's recent story about the July 4th heat wave, which was virtually impossible without climate change. I think Cindy's going to do that. Okay, first we are going to walk through the data pipeline, and this is from analysis, from the data to analysis to media publication. And Chris, that in some ways starts with you. So tell us about how you use data in your work, and what is one thing that you wish science journalists and or the public understood better about data, about statistical models, about uncertainty?
Great. Thanks, Regina. Yeah, it's a pleasure to be here. So in my work, again, I came from a background in meteorology originally, but I've done a lot of work related to sea surface temperature, long lead forecasting, filling in gaps in satellite-derived ocean winds, soil moisture prediction. More recently, wildfire risk analysis and wildfire propagation, and some of the human related impacts there as well. So the nice thing about these kinds of data, and you said one thing, and I'll come back to the one thing at the end of it, but these data are unique compared to what we learn in most introductory statistics classes, and that's because for several reasons. One, there's multiple scales of things going on at once. Like if I'm interested in a flood event in Iowa, for example, it could be related to crop phenology. It could also be related to local moisture transport from the Gulf of Mexico, but also El Nino. All these things are working together. And that's something that we're not used to looking at traditionally in statistics. And similarly, we aggregate data or we disaggregate data because maybe we're interested in a global number, or maybe we're interested in a number just for somebody's farm field, in Iowa. And a lot of these data come with observational gaps, and those have to be filled in some way. And that's been done for a long time, and it's done pretty well, honestly. But this is something that could might come back up later in this conversation. And then there's extreme events, which is what one of the main topics here. And the interesting thing about extreme events, things that are in the tails of the distribution, is that a lot of the things that we're used to in traditional statistics don't really apply there easily, at least. And so there's a lot of work that's been done in recent years to make that happen. So coming back, the thing that ties all that together from my perspective is that there's dependence. And what I mean by that is that things nearby tend to be related in time and space. And if we don't take that into account, then we don't characterize uncertainty properly. And so you'll hear that in perhaps in some of my other comments later on. But that's what I'd like people to recognize, is that uncertainty management relies on us being able to properly account for the real situation, interactions of different processes, as well as time and space. That's kind of my nutshell answer there.
I love that. I love this idea of dependence in time and space and uncertainty, because these are nuances that often get left out along this way to the public. Okay, now let's talk about how that data that Chris just talked about becomes digestible. How is it digestible information? And Jason, I want you to take this one. How do you take that kind of data that Chris is working with, and what do you do with it? And I'm particularly interested, how do you decide when and how to simplify things in a forecast or an explanation when you are communicating with different audiences, with the public?
Thanks so much for the question, Regina, and it's a pleasure to be here. So as a follow-up to Chris's comments, when we receive data and we're thinking about communicating it, we sort of have three goals in mind. Number one, that the data that we're presenting is understandable. Number two, that it's useful so you can make a decision, hopefully based on it. And number three, that it's trustworthy. So you kind of want to have those sort of three pillars when you're presenting data. So like in terms of like making something understandable, for example, if you're showing someone a visual, some sort of graphic, or maybe it's a chart, you want to make sure that it's clear and it's not subject to misinterpretation, and that it's not doesn't take the person, 3 minutes, 5 minutes to understand it. It should be apparent immediately what your key message is. when you're presenting that information through a visual. And so you want it to be clear, you want it to be understandable. In terms of it being useful for making decisions, yeah, you want the information that you're presenting to be actionable. For example, tomorrow in DC, we may have code red air quality, and we'll have some numbers to sort of describe, what code red means. But you're also going to want to provide to people actions that they should take given that information so that they can protect themselves, they can protect their families. And so again, you want to use that data and you want to be able to provide information that's complementary to that data so people can make good decisions. And then, yes, you want it to be trustworthy. And that's when communication of uncertainty becomes important because you can describe data a certain way, but if you don't explain the full range of possibilities when the information is uncertain, you can lose trust that way. And that sort of ties into the question you asked me about simplification, right? Because we get so much data. For example, when we're making a snowfall forecast during the winter, we might be looking at, 10, 20, 30, 40 different simulations. And if it's a difficult forecast, those simulations are going to vary. The forecast is easy when they all agree. That's the easy part of the job, but that's not often the case. And it's not the case in predicting snowstorms, and it's sometimes not the case when describing a complicated climate change finding. So what you want to do is you want to sort of break down the range of possibilities to people in an easy to understand way. So what we do with the snowfall forecast, for example, is we tell people, okay, this is what we think is most likely, but here's the possibility that the snowfall forecast will be less than we predicted. We call that the bust scenario. And then we have a boom scenario. That is, what's the possibility or what's the probability that the snowfall will exceed the most likely forecast? So you're basically, you're not copying out of the forecast. You're telling people what you think is most likely, but you're explaining the full range of possibilities to help them better understand the forecast and also hopefully inform better actions.
This is one of the things that I love about capital weather is that you do make it understandable, and the boom or bust is one of my favorite cute language things to attach to what I know are very complicated ideas underneath. And I just want to put a pin in this idea that about trustworthiness of reporting results around uncertainty. Because sometimes communicators are taught, don't talk about uncertainty because then people lose trust. If you say things are uncertain, they extrapolate. But here you're saying, no, that actually increases trustworthiness. So let's come back to that at a certain point. All right, Sarah, now you're the end, you've got science journalism, you've got to bring a lot of this information to the public and tell a story with it. And tell us a little bit about your process, and also same thing I've been asking everyone, what is one thing that you wish statisticians or the public understood better about what you're doing in science journalism?
Yeah, so I cover climate impacts really, and often that's extreme events like hurricanes and wildfires and heat waves, but also more subtle, longer term impacts like drought or effects on water systems and food systems. And so I use climate data all the time in my reporting, both kind of on the front end to help me figure out, okay, what's the story that needs to be told? And then, certainly in the story itself, I always want to be backing up, journalism. I think like the most powerful stories that journalists can write about climate change are the ones that meld personal experiences of people affected by climate change with, really robust and rigorous science that is rooted in data that is well explained, that shows that this is not just one person's experience, like this is a broader trend. And so data is super, super important for that. This idea of like, what do I wish that scientists or statisticians understood? And then not that this is something that they don't understand, but a thing that I always try to emphasize is that like we have the same goal, I actually think that reporters and scientists are very similar in that, like, we want to understand why the world is the way it is, why, like, what is happening, why is it happening? We want to be accurate. And we also really need trust, like Jason said. And I think that trust often comes from transparency and accountability. And so, you'll notice that Washington Post stories, particularly where we do our own data analysis, we have some really brilliant data reporters and meteorologists on our team, and they'll have a whole section like a methodology section, effectively at the end of the story, so that people who are curious and want to understand how we got the numbers that we came up with can understand that. Another thing that I really like, and actually this is something that Jason does that I have always really admired, is that at the end, when Jason was my colleague at the Post, and I know he will continue doing this now that he's running Capital Weather independently, is making a projection at the beginning of the winter for what will the snow be like this winter in DC. And then they always do kind of a postmortem and say, like, did we get it right? Did we get it wrong? And I think that part of the reason why Capital Weather is so trusted, like, I mean, probably has one of like the highest trustworthiness ratings of any institution. If Gallup did that analysis, I'm sure that that's what they would find. But I think it's because, like, they say, okay, we got it right, we got it wrong. Here's why we made the decision we did, or the projection that we did, and so that kind of transparency, like, journalists have it, and Jason is both a journalist and a meteorologist. He's kind of like a unicorn, but journalists have it too, right? We post corrections when we get things wrong. And I think that I just, want to emphasize that, like, those values are the same of wanting to get it right, wanting to be trusted, and recognizing that showing your work and also owning up to it when you make a mistake are really important for trust.
What you're describing is exactly the scientific process, right?
Yeah.
Publications and journals. It strikes me though,
it just had a very fast time frame, which is one thing, I guess maybe another thing that I do wish scientists understood is that, like, I mean, and this is true of attribution studies, which I'm sure we'll get into, but like a lot of the time, these studies that try to look at, okay, what role did climate change play in an extreme event, they'll come out like 2 years after the event, because it's going through the very long and rigorous, but also a little bit slow process of research and peer review and everything. And I think that scientists often don't want to say something, like, they don't want to get out ahead of themselves. They don't want to say, oh, this event, like, if before an attribution study is done, they might not want to say, like, this event, climate change likely played a role. But the reality is that people want to know about the event now, right? And they're probably not going to care about a study that comes out 2 years from now, unless it was like unless it's a Hurricane Katrina type thing. And so I think that striking that balance of giving people information, not just really robust and rigorous information, but also information that is relevant when they need it. That's the other piece that I think that journalists have to focus a bit more on. And sometimes there can be a little bit of like a reluctance to say something before you've like analyzed all the data on the part of scientists, which is understandable, but it's also, you also want to make sure that when you do provide information that it's usable and it's going to reach people. Sorry, I interrupted you.
No. This is perfect, because one of the things that strikes me as we're talking about this idea of trust and this trust along the pipeline, we're also trusting the public, though, in a way that you can go to the public and say, here's the range, and oops, we got it wrong. And I know that scientists have a difficult time with this. Statisticians do. We want to talk about uncertainty. We want to be trustworthy. Is there any blowback to doing that you found, being too trusting of the public to be able to handle the ambiguity that you're communicating?
My bias is that actually the public appreciates complexity, that readers like. I mean, when I used to cover sort of basic science and I wrote about space and things, I would write about like neutrinos and gravitational waves and super complicated physics things. And editors would always be like, I don't know if people are going to want to read about that. And then those stories would be so, get such a reaction. I would get emails from readers. Like people are capable of understanding complex concepts. You just have to use accessible language. I think like that is my sort of like, soapbox that I get
Mhm.
on when I talk about science communication is that like you don't need to dumb down the concept. You just need to make sure that the language doesn't require you to like have a dictionary in front of you, right? To like avoid jargon, look for metaphors that can help people understand a concept that is maybe a little bit difficult to get on the first try. Um, and I just think that I mean, it's true that, in this time when we're like bombarded by information, and it's hard to know what is reliable. People might want simple answers, but I think it's even more true that amid that, like barrage of influencers and AI and like all of these other sources of sort of dubious information, if journalists and scientists and people who are trying to communicate science can say like, again, that sort of combination of transparency and accountability, here's how we got to where we, what we're saying, and like you can trust us that we'll tell you if we turn out to be wrong. Like those things, that complexity is, I think a lot of people or that nuance is something that people do crave because it signals like, okay, this is someone who, doesn't have an agenda and is trying to, like I can see where they're coming from, right? I can see their work essentially.
I love that you mentioned editors and then dropped it. But that's a very fascinating thing. Maybe we need to convince editors that the public can trust us more.
Oh, yeah.
But Jason and Chris, do you have anything to add? Do you agree?
Yeah, I mean, I think it kind of there are people who don't have a lot of patience to sort of sift through the science or to read sort of an in-depth news story or to read an in-depth forecast discussion, and they just want to know the answer. And they're just going to go to their weather app and, you know, we may say, there are going to be 6 to 10 inches of snow and there's a 30% chance it'll be less and there'll be a 30% chance there'll be more. And they'll just go to their Apple app on their phone and it says 7.3 inches and that's good enough for them. And, I think that's fine. Everybody, different consumers, have different needs, right?
Mhm.
I think the unfortunate thing that can happen though is that, when the app is wrong because it doesn't provide the nuance, it doesn't provide the range, um, it reflects badly on weather forecasting overall. It's like people project that one answer they get on their app to all of meteorology, which is really unfair because there are people who are trying to employ best practices, who are trying to explain that this is an uncertain science. And like, it's not that we don't know anything. Like, meteorology is like, it's an incredible story about how much it's advanced, in recent decades and sort of how much numerical models can do and how sophisticated they are. I mean, it's really a marvel of scientific discovery how well we can predict the weather, but still, like when you're talking about like the difference between 1 or 2 degrees, being the difference between, like 5 inches of snow or bare ground, these really small scale changes like are still like difficult for even the best models to pin down. So I think like we still do have a bit of a disconnect between sort of the what I would call the careful and conscientious consumer of weather information and the impatient consumer of weather information. And so, we tend to our audience tends to be the more sort of conscientious weather consumers, but It's more of a challenge to kind of bring in those people who maybe they just have a lot going on in their lives. People are busy. There's a lot of information coming at them, and they just want to look at their app and see how much snow is going to fall. And um, they get their answer. It may or may not be right. So that's just a reality, and we just got to kind of continue to work to educate as many people as possible about what we know and what we don't know, and what the credible sources of information are. The more we can do that, I think the better off we'll be.
Regina, can I just say one thing? This is great. I'm learning a lot already. But Sarah's comment about kind of the speed at which we can get information out, like attribution. I mean, that's a really important point. Um, and not that I can stick up for the academics of the world, but we all wish that peer review stuff happened faster. But there is a tension there, though, between something that comes out fast with a lot more assumptions and simplifications and something that might be a little bit more in depth and perhaps more respectful of what's really going on in the background. And sometimes that stuff takes longer. And so I guess I want to say that what sometimes gets lost when things come out fast is this notion of not that people are deliberately hiding the uncertainty. It's just that it's not always clear that this particular method may have all these assumptions behind it that are actually potentially not so realistic, and making that attribution comment more uncertain than it might actually they might think it is. Anyway, that's just my brief comment about that.
The nuances and assumptions that definitely did not get communicated to the public. No one would have the stomach for that. We have a question from Mary Salvana that I think fits right in with this. She asked, with one extreme weather disaster after another, can experts or statistical models still give the public confidence that these risks can be meaningfully modeled and anticipated far enough to allow time to prepare? Any thoughts about that?
I feel
Anyone?
like Chris should take the first
Oh,
stab
right.
at that.
Yeah. Yeah. Thanks, Mary, for the question. Yeah, how people perceive it is less clear to me, but I think it's sort of like, and this discussion might come up some other point here, but like part of it is really the communication issue. That if we're still talking about 1 in 500 year floods, that's not a realistic way to think about things anymore. And climate scientists know that, and meteorologists know that. They know that it's non-stationary, and we have to come up with better ways to communicate that information. So I don't think it's the fact that we can't do it. I think it's more the fact that we're not good yet as scientists at communicating that as well as we could. And I think Sarah and Jason probably have way better thoughts about that than I do. But things like just annual exceedance probabilities, that doesn't sound like it'd be any easier. But if you tell somebody that this some event is 3 times more likely to happen this year than it was last year, maybe that helps. Or if you say over the course of your mortgage, there's a 45% chance that you're going to have a flood. Something like that might get people's attention more, and it's something we can actually do.
Um, I don't know, do you want to hop in, Jason? I have a thought.
Why don't you go first?
Yeah, so I think about this a lot. I covered Hurricane Helene quite a bit. I spent long time in Western North Carolina after the storm. And I remember hearing a lot from residents that they were not prepared. They felt like they had not been warned about how bad the flooding was going to be. And last year, after hearing this again and again and again, I kind of set out to try to figure out, okay, did the warnings fail? Like, did we not have warnings? And when I looked back at the timing of, National Weather Service alerts and the forecasts that they were having, and not just the forecast for rainfall, but like the forecast for flash flooding and where the flash flooding would be, they were incredibly accurate. I mean, really, like, they were giving warnings about flash flooding in North Carolina at the same time that they were giving warnings about storm surge in coastal Florida. So it was good. It was the same sort of time scale of warning that you would expect for a hurricane. But the challenge was that people in North Carolina, because they had not experienced something like this in living memory, they just we all do this as humans, right? We assume that our past is a guide to the future. We think like we have this frame of reference, and it's really difficult to communicate to someone that they are going to experience something outside of that frame of reference, to get them to imagine what that would even look like. And I think that that's where, so this story that I wrote with my colleagues, we investigated, we found that evacuation patterns in inland areas show that way fewer people evacuate from inland flooding because they're not as accustomed to it as coastal residents are. There's also just been less investment in preparing people for inland flooding, even though that is actually the most dangerous hazard from hurricanes right now. But I do think that really underscored for me when I write about, if I'm doing a story about like a Category 5 hurricane is in the forecast, I am really in the future going to like think a lot more about how do I communicate not just that there's risk where this storm is making landfall, but that people who live inland who are probably going to receive a lot of rainfall, that they are actually potentially in even more danger, right? Because they're less informed, right? And it's harder. I mean, flash flooding is also hard to predict for all kinds of reasons, but there are good tools out there. The National Water Center, I think it's part of NOAA, has some new like flood mapping tools for freshwater flooding or inland flooding. Looking at like all of the sort of creeks and streams and rivers around the country. I think that thinking about how do we help people visualize, okay, what does 10 inches of rain look like? Like if 10 inches of rain falls in my area, like what is that going to look like? Has that ever happened before? I think focusing on how do you take something that is going to be outside people's frame of reference and try to give them a frame of reference for it is both like it's a huge challenge, right? But it's really necessary, as we saw in North Carolina, because a lot of people who lived right on the river, they saw the National Weather Service warnings, but they didn't internalize that like that was them who was in danger and that they needed to get out of harm's way. And the consequence was a really devastating death toll. So yeah.
Yeah, and I can layer on one additional thing on that. I think Sarah made a lot of great points, and the forecasts are generally pretty good for most events. I mean, there are some events that sneak up on you. Certain tornadoes, can be hard to predict with a lot of lead time. Certain flash flood events, if you look at the flood in Texas, which the flood disaster at the camp last summer, just a year ago, that didn't have a ton of lead time, although flash flood warnings were issued for that. I think, the point Sarah made about, predictions being outside the range of people's experience being difficult to conceptualize and take action on is really good. And I think an additional thing that I'd want to layer onto that is just that typically the people that, or a lot of times the people that suffer the most during extreme weather events, or even fatalities during extreme weather events, are the people who are most disconnected from information. Maybe they have cognitive impairments, maybe they're older adults, maybe they're poor, they're not as plugged into information and all the tools Sarah was talking about that we now have in the toolbox for understanding these hazards and disasters. So I think a real challenge for the weather and climate community, and as well as sort of emergency managers, first responders, is reaching the vulnerable groups, because often they're the ones who are most disconnected. I remember the New York Times did a study. I did a report on the people who died during Hurricane Sandy in 2012, and it was almost all socially isolated people, people living alone, um, people who just might not have had as good as information as most of us do. And so I think it's getting the information to those who are most vulnerable is a real challenge. It's something the community needs to focus on.
So I love this question that came from Mary. Thank you all panelists. And I just want to remind anyone, if you have questions, go ahead, put them in the chat. We'll try to answer them as we go along, or at least at the end. And I want to pivot a little bit from this and talk about trustworthiness again and talk about data. So the process, that whole data pipeline process, how well is it working or not working right now? What is happening with the government databases, archives? What is something around weather or federal data that we used to be able to assume would be available, we can no longer take for granted? And Anka Rasper asks this: as an environment desk at International Media, we wonder how trustworthy the data is that we now get from US official resources, particularly in institutions where many climate scientists were fired, NOAA, et cetera. And how should one deal with that?
I mean, I can start off. I mean, I think the weather and climate information that we're receiving from federal agencies is still credible. I think the question is, um, because of some of the cuts to staff and cuts to certain research resources, um, do we not have as much of it? And is it impairing some of our ability to communicate and to forecast? I mean, as an example, with the DOGE cuts of the National Weather Service, their workforce has been reduced. There's also been attrition due to retirement. And so there has been a reduction in the number of weather balloons launched. And there are questions being raised now as to whether that's affecting the forecasts. And we haven't yet seen an analysis yet, an objective analysis as to what specific effect the reduction in weather balloons is having. But a lot of meteorologists know that this data collected by weather balloons is really, really important for sort of being ingested by these computer models that help us predict severe thunderstorms, that help us predict, what areas might be most vulnerable to tornadoes on any given day. So I think, the fact that some of these agencies are understaffed may have an impact on some of the products and services which are coming out of it. It's not intentional. I don't think there's any sort of like deliberate, misinformation being put out by, agencies that are responsible for climate and weather information. But I think it's just sort of maybe there may be some consequences as a result of the fact that the staffing has gone down, the resources aren't what they were. So, and also it's just when people who are really experienced, when they retire, and they're either not replaced or they're replaced by junior people, you lose that institutional knowledge, which is really important. You talk about trust, and if you lose officials who have been around for decades and who have connections to the community, and they just go away, and they're sort of responsible for being helping to, like in a weather service office, if like a senior person retires who had connections with local emergency managers, and that connection is no longer there, then maybe the word doesn't get out to those emergency managers, or maybe the emergency manager doesn't have the same trust because that relationship has been broken. So, I mean, these are the things that, like we're thinking about sort of in the weather space, but I'll let Sarah and Chris weigh in with any other implications that they're thinking about.
Chris, do you feel like statisticians are talking about this loss of data, like the weather data?
Yeah, I think so. I mean, we're pretty good at dealing with missing data in general. Like, think about this, if you lose radio or weather balloon, radio sun sites, it's effectively missing data. Satellites, maybe, we're losing stuff there as well. And we're pretty good at that, but that's all usually assuming that they're sort of missing at random. And so that's not really what's happening here. And we're not very good in the environmental space of dealing with things that are not missing at random, and especially when there's this dependence in space and time. And there is work that's been done in statistics on preferential sampling, and this would be preferential removal. So I think we can help with that, help mitigate it, right? But what that's going to do, it's just going to, sort of Jason's implication, it's going to almost surely lead to more bigger uncertainty bands. And so we can mitigate it, but we can't solve the problem. We can't bring back the data. It's always going to be there. So we can mitigate the damage, but we can't fix it. So I think it's good because we're thinking about it, and a lot of people are doing research in this area. So I know this isn't a research discussion, but I just want to make it clear that we're aware of it and we're trying to bring some of these tools to bear on it.
I like what Jason said, and this fits in with Chris. The question was, how trustworthy are the data? And Jason opened by saying, still credible, just less of it, fewer data. And so what I'm hearing is, okay, it's still good what we're getting, but we just have bigger uncertainty bounds now. So Sarah, how can journalists take that into consideration then when reporting? What do you do with that?
Yeah, I mean, communicating uncertainty is definitely hard. And like the sort of the measures that scientists use, like statistical significance and things, like that's not how a non-scientist generally thinks about the world, right? And it's not like that's probably may not even be a term that they're familiar with. And so there are other ways, I think that like something that the IPCC does, the Intergovernmental Panel on Climate Change, which is kind of like the world's preeminent body on climate research, they'll, categorize things as like very likely, more likely than not, like virtually certain. And so that kind of language, it's not as precise as the way a scientist might communicate that in a like journal article or an academic paper, but it communicates like the gist, or the essence of what the uncertainty is. And so, I mean, I think that, Jason's right that like for the most part, when I use NOAA data all the time. Like I'm constantly looking, or I'm looking at the National Drought Monitor, or I'm looking at like um, you know, sea level rise projections or things. And most of the resources that I use, and like the ones that I link to in the tip sheet, they're still there. And I still, I mean, I talk to scientists, federal scientists all the time, and I know that they are still like very committed to getting good data for the public. So, I think that, I wouldn't say that like, oh, now we have like don't trust your weather forecast as much because there might be some balloon launches missing, right? Like I definitely would not go that far. I don't think any of us would. I think, there's still, but I think that yeah, I think, the other thing that, I know we've talked about a little bit is just this question of communicating uncertainty when talking about the role of climate change in some of these really extreme weather events that we're seeing, like this crazy heat wave, or the crazy heat waves that keep happening. And that's somewhere where I think that in the past, journalists were maybe too cautious in communicating like the level of scientific consensus about climate change and the effect it's happening. It's not a debate. And we see the evidence all around us. And there's an awareness that uncertainty can be weaponized by those who might want to suggest that it's not as big a deal, or we don't really know, that it's humans, that it's, greenhouse gas pollution, that these impacts are happening. But I feel pretty strongly that if you're covering a disaster of the kind that we know is influenced by climate change, particularly the ones, and the National Academy's report talks about this, that like the attribution science around heat waves, and large scale heavy rainfall events, that's very robust. And it's based on pretty straightforward physics. Like the fact that any heat wave can get hotter now because it's starting from a higher baseline, like that's pretty straightforward. The fact that the atmosphere can hold more moisture because it's warmer, and so therefore the rain event can drop more, has the potential to drop more rainfall. That's basic physics. I think we should not shy away from communicating that and making sure that like a reader doesn't come away from a story about these heat waves and not have at least, acknowledged high up, like that this is climate change contributes to these events, that they're going to get more frequent and intense as the world continues to warm. In the tip sheet, I have language, the sort of like my preferred language of, ways that I like to phrase it so that you're not directly saying climate change caused this, because we can't say that with the data, but we can say a lot.
So this actually pivots to something that the four of us started talking about before this webinar. Sarah, your tip sheet was wonderful with all the climate attribution sources, and I'm just curious, what do you do when models disagree? So statisticians know, and this is a question for everyone, statisticians know that models are built on assumptions, and there are so many assumptions behind everything. You're not always going to get the exact same numbers or the exact same predictions, and they're giving uncertainty in probabilities and confidence intervals and things like that we're not communicating to the public. But of course, the public want, well, they would, I think, prefer a yes/no answer. But we can give them a little bit of ambiguity in language. But what do we do when the models disagree?
Yeah, I mean, I think that, a lot like the sort of most famous rapid attribution group, World Weather Attribution, they're based out of the UK. They do these like, what I was talking earlier about like making sure that science comes out on a sort of timeline that is usable by journalists. Like they have designed a methodology to rapidly conduct an attribution study of an extreme event and be able to come up within a few days with an assessment of like, did climate change make this more likely? Did it make it, what they do is they basically run a whole bunch of models, run that event through a whole bunch of models, some of them in our real world, that is 1.3 degrees Celsius warmer than pre-industrial, and then some in a, hypothetical world where our temperatures have not changed. And they sort of use the difference between how does this event look in the real world versus in the unclimate changed world. And so their whole methodology is designed to, the models are going to give an array of answers. And the more they agree, the more confident you can feel in the answer. And they, but also, they'll present a range, and often I'll report the range. I'll say like this, they said that climate change likely, made this event 30% more intense, but the contribution from climate change could be as high as 50%, right? You can use that kind of language. If two different studies come to different conclusions, like that's interesting and important, and you have to acknowledge that. And maybe try to figure out why. Like, is it because they use different methodologies? Is there, or maybe it's just we don't know yet, right? Like I cover the climate tipping points a lot. So this idea that there's like thresholds past which certain aspects of our climate system are going to just like collapse, like the Amazon rainforest or the Atlantic meridional overturning circulation. And there's a ton of disagreement about that. And like, that's part of the story, right? I think that part of the job of journalists is not just to tell people what does science say, but also like how does science work, right? So that they understand that like, just because something was published in an article in a journal, or just because somebody works at Harvard, it doesn't mean that they're like the final word on everything.
I'm curious, I want to hear from Jason and Chris. Any thoughts about this? The climate attribution?
Yeah, I mean, I think, just sort of reiterating sort of the point we've made throughout this whole conversation, which is that um, I think it's a job as a journalist or a science communicator to sort of mirror where the science community is on an issue. And and I think to Chris's point, sometimes that can take time, for those sort of strong conclusions to develop. But I think once they have been established, you lead with that, as Sarah said, like if you're having a heat wave, which is beyond anything you've experienced, you'd be committing journalistic malpractice if you didn't discuss the role of climate change in that, in that narrative. So, but yes, there are, of course, going to be situations where, that our state of understanding is uncertain, and where the science is still immature and where more time is needed, to Chris's point. And I think in those situations, that's where you do communicate uncertainty. You do explain the differences in methodologies, and you try to be open and transparent about that, because if you're not, then you can lose trust. Getting back to the whole issue of trust, if you tell people it's going to be one answer when it could be a whole bunch of different answers, and then 5 years from now, the whole state of understanding on an issue has changed, and you didn't previously communicate that uncertainty, then the respect people will have for you as a journalist will diminish. And people have long memories. I mean, like people look back at predictions that Al Gore made, and he's made some good ones and he's made some bad ones. But like, there's YouTube, there's social media to sort of resurface bad predictions that people have made from the past. So if you don't qualify them, and if you sort of sensationalize the science, then that can backfire. So I mean, I think it's like, okay, you do two things. You definitely make clear front and center what the vetted, established science is. But
Mhm.
when the science is uncertain, you're open and transparent and honest about it. And that's kind of where I fall on this.
Mhm. One thing that's a little different from forecasting, when we're talking about the climate change attribution, it's retroactive. We're saying how much did climate change contribute to this? So it's a bit of a conceptual question with some counterfactuals in there. And yesterday, the four of us started discussing, can we really say, yes, climate change strongly contributed to this hurricane or this heat wave? Statisticians think in different ways. Chris, do you have anything to add to that?
Yeah, I mean, what's in the background here is causality, right? And so there's more than one approach to dealing with causality, and in the approach that Sarah was talking about, where deterministic models are run under counterfactual scenarios, and then climate change scenarios, and then the ratio of those things are presented as some kind of a likelihood of that making a difference. That's all well and good, but there's a bunch of assumptions back there in the background, and only recently have people actually been using data to try using different kinds of causality approaches with data, not using the models to try to show attribution. And I guess it's very much state of the art, right? It's using methods that are recently or being developed. AI is playing a role there. AI is allowing us to do estimation now on scales that we couldn't do before with extremes, as well as prediction. That's a whole another ball game. But anyway, I agree with everyone here, but I just think that there's a lot that we're assuming, that if somehow we could communicate that a little bit better, it would be good. It doesn't diminish it. It just, as Jason says, it's all about trust here, and that's what we're trying to. I think we all have the same goal, and I think Sarah mentioned that earlier.
Chris, that actually leads to a couple questions from the audience. They were essentially saying, okay, we've got AI now. So what's the value of a human statistician, especially if we have less and less federal data? So I exaggerate a bit, but what is the role of the statistician now when we have AI? And Jason might have thoughts on that as well. Do we need Jason? Do we need capital Web?
This is a great question. Yeah, we could start a whole new podcast on this topic. Um, I mean, to make that a short answer for me, there's so many different ways that you can use AI, and what we're using it for now is to be able to do estimation and inference on problems at scales that we couldn't do before. We're still using the same statistical models, but we're implementing it with AI to help us estimate those things much better. And I think you could say the same thing probably about weather forecasts by generating huge ensembles instead of a few. But I'll let Jason and Sarah speak to that.
Jason?
Sure. So, yeah, on the question of AI, I mean, yeah, AI is certainly making a difference now in terms of, it's another tool in the toolbox for weather prediction, and there are, an increasing number of AI-driven weather prediction models, which means we have more simulations we can look at, more simulations we can look at, the better understanding we have of the uncertainty in a given situation. So that is all excellent. And some of the AI models are really good. Like there's the Google DeepMind uh, computer model was the best at predicting Atlantic hurricanes last hurricane season. So they're not all the best, but some are showing tremendous progress. So in any event, I think certainly AI is an incredibly promising technology. It's giving us more things to look at. And I think there are a lot more gains in weather prediction to come because of it. At the same time, I think, there is, and we're seeing this on our social media and it's sort of in the feedback we're getting from our readers. There's a little bit of a mistrust in AI because AI does make mistakes. There's a lot of AI, what people call AI slop out there. People generate AI and it's not vetted. It has mistakes. It's a mess. And so I think like from the standpoint of trust, our audiences still really do appreciate if they know something is coming from an actual person who's like looked at the data information, like analyzed it, kind of filtered it through their own mind and then presented it person to person. So, and I think that's sort of at the core of what we're trying to do at Capital Weather is, we lead off our forecast by saying always a human at the helm, and we provide a forecast narrative each day. And yes, we're looking at the AI data, and we're using AI to build visuals on our site. We're using AI to sort of bring to process data, to do things more quickly that previously took a lot of time. But it's a tool in the toolbox, but I don't think it replaces humans, but it can certainly help us out and lead to important gains. But you have to use it the right way.
So I see Amber, so I think it is time to wrap up. We've been going an hour for this. I just want to thank all of our speakers, Sarah, Jason, Chris, for fascinating discussion. And let me turn that back over to Amber for final wrap up.
Yeah, I will just echo that, thanking Regina, the American Statistical Association, all our speakers, and all you attendees for joining us today. And if you have any additional resources that you want to share on these topics or any science writing topic, you can drop us a line anytime at connector@casw.org so we can build that resource for everybody. Thanks and bye.
Thanks, everyone.